So we are working on problem 100 and in chapter 3, and taking a look at this problem, we first of all wanted to add the fractions. So I need to do, the first thing I need to do here is actually go through and factor the denominators. So taking a look at that. So taking a look at these, I want to take a look at this denominator and factor them both. So if you are following along right now, I'll give you a couple seconds to pause that, and you can factor it, and then I'll go through and show the next step. Okay, so if you have done that work already, so your fractions should now look like this. My numerators stay the same, but I have now factored the denominators. Now a couple things with these. If I take a look, they both have an x plus 4 in the denominator. So when I'm trying to get a common denominator, they both already include that. However, the left fraction does not have an x minus 7. So what I want to do is I want to add the x minus 7 to it. And I'm not actually adding it, I'm actually multiplying. So I need to multiply x minus 7 over x minus 7. The reason why I need to do x minus 7 over x minus 7 is because that makes my giant 1. So I'm actually multiplying the problem by 1. But now if we look at the denominator here, I have my x plus 4. I have my x minus 7. So that is the same. The problem now is the fraction on the right does not have a 3x plus 1. So using the same idea, I'm going to multiply by the 3x plus 1. Now my denominators are the same. I have a common denominator. It is these three factors multiplied together. I am not going to multiply them though. I'm going to keep them in factored form. So the next step whenever you're adding fractions is I need to multiply this, I need to multiply this, and then add them together. So again, if you are working on this problem, please pause it now and do that next step before I show you how to do that. Alright, so if I multiply out the numerator on the left and the numerator on the right, I'm going to end up getting this. Notice that the denominator has not changed. I had this as my common denominator, so now I'm writing it as one fraction, but what I'm doing with that is I'm taking the left part, which now is that, and I'm adding it to the right part, the right side fraction. Notice I have them in parentheses as well, and the reason why I'm doing that is because if this was a subtraction problem here, if that was a subtraction, I would need to distribute the negative, which I will talk about in the next problem. So now what I need to do, my next step is to simplify the numerator. So I'm going to now add that together. Again, if you're working on this problem, pause it now. Okay. So I have this fraction that I started off with. I'm combining then the numerators, so when I add those together, I will end up getting this fraction. Again, my denominator I'm going to keep in factored form, because my goal now is to see if I can factor the numerator, and if that can get factored, I want to see if anything will reduce. Well, the numerator has all factors of 5, so I can factor a 5 out, giving me then 5 times x squared minus x plus 10, and my denominator will still stay the same. So there that is. Ooh, one mistake here. This 10 should be a 2. Now I need to see if I can factor this, x squared minus x plus 2. So if I make a diamond problem, the top of my diamond problem is a 2x squared. The bottom of my diamond problem is a negative x. So do I have factors of 2 that add up to a negative 1? I do not. So therefore it is not factorable. And that is my final solution. So we've now taken care of problem A and worked on that, and problem B as well. And now we're taking a look at problem C. Hopefully when you're looking at problem C, you notice the denominator right away is a difference of squares. So when I rewrite the denominator, I get that. Now looking at the denominators, I have an x plus 4 and an x plus 4. The left fraction does not have an x minus 4, so I can go through and multiply the left-sided fraction by that. There is an easier way to do this problem, and I will show that in just a minute. But normally students don't see that. So I will just talk about doing it this way. So I'm going to multiply by x minus 4 in both numerator and denominator. I now have a common denominator. So again, my goal here is to write this now as one fraction. Again, my denominator now is the same. It's x plus 4 times x minus 4. My numerator, again, I'm going to multiply that, so I'm distributing the 2. So I get a 2x minus 8 minus 4x minus x squared. So when I'm simplifying this now, I need to distribute that negative. So it actually, my numerator becomes 2x minus 8 minus 4x plus x squared, which can further be simplified as well then to x squared minus 2x minus 8. Again, my denominator is still the same. So my fraction is now that over x plus 4 x minus 4. Now I need to check my numerator and see if it can be factored. So pause it now if you need to work that out and try to factor it, and I'll give you a couple seconds to pause that. Okay, hopefully you've worked that out and found out that the numerator factors into x minus 4 times x plus 2. Again, my denominator is the same. But now I have a giant 1 with those two, and x minus 4 divided by x minus 4 is 1. So my solution to this is x plus 2 over x plus 4. That is now reduced. As previously stated, there is an easier way to go about this if you can work with some numbers. So the left side of this fraction is 2x plus 4. As previously stated, the denominator is a difference of squares, so it's x plus 4 times x minus 4. But the numerator here can also be factored. I can take an x out of both. So if I take an x out, I have x times 4 minus x. You may notice that I have a negative x and a positive 4, which is the opposite of what I have here, which is a positive x and a negative 4. So the little trick on this one is instead of factoring out an x, factor out a negative x. So if I factor out a negative x, this actually becomes a negative 4 and a positive x. So the numerator is now negative x times a positive x minus 4. Meaning that I have a giant 1 right here, and my fraction now becomes, or this problem becomes, 2 over x plus 4 minus a negative x over x plus 4, and I already have a common denominator. So my numerator then is 2 minus negative x. 2 minus a negative x is going to be a 2 plus x over x plus 4, which is the answer we had before. I just switched around the order of the x and the 2 in the numerator, so it's x plus 2 over x plus 4. Normally students do not see that part of factoring, but if you do notice that, the problem becomes quite a bit more simple.